Hey guys, this is Wanderson from MedLab VFX. I'm gonna show right now how I created this bridge, this cartoon bridge in Houdini, just using procedural techniques. We are going to create the trees, the bridge itself with the fence, and these islands here. Let's get started. Here is the project file. This project file will be available for free at Gumroad. You can find the link in the description and download the Houdini project for your studies. Let's get started how I create, for example, this tree. Simple tree with few parameters here, like seed, height, noise amount in the trunk, the colors. Let's dive inside and see how that I construct these trees here. First, just create a simple lines with 2 points. I resample that point. I remap the curve U attribute because, for example, in the resample here, I enable this curve U attribute. But using just Vex, I invert the direction of curve U and apply some noise here using the curve U attribute with a mask. For example, without curve U, if I apply the noise should be applied the entire tree here, for example. If I increase all the tree, the trunk of the tree, will be applied the noise. If I disable that and enable the remap curve U, I apply the blend just in the curve U attribute here. I resample that again, move to origin, move down a little bit the roots, the trunk, just a simple sweep here. Simple sweep, just some columns and radius change here with end caps, and a little twist. For example here, I just apply a little twist. The next step is carve a little bit the top of the trunk spline, scatter a few points, point jitter a little bit, fuse all the points that are nearby, apply some p-scale here, random p-scale by Y attribute, create some ID, and copy a few spheres here to represent the leaves. Apply some noise, normals, because this style of the leaves should be faceted. Apply the color and merge back with the trunk. For these branches here, let's see the branches. Just using that spline of the trunk, with that points here that I scatter to make the leaves, we are just array that points back to the spline and merge with the original point jitter points here. Apply a add to connect all the ID points. That's because we created this ID here. ID equals PTNAN just to represent which PTNAN is the same from that. For example, this here, this bottom PTNAN here is 0, 1, and that one here is 1, I think is here, yes, is here. When I merge that point and that point should be connected using the add attribute here. Apply a sweep with p-scale along the curve and merge back with the trunk, applying the brownish color. And that's it for the tree, just a simple cartoon tree. Let's see how I created the bridge. The bridge is a little bit more complex than a tree. Let's dive inside and see each step for the construction. The first, we need a start point and an end point. The start and end point position for the bridge. Merge both points. I ensure that here, just to apply scale 0 in the Y. I create a line from these points, and that's it. Just first step, just spline. The columns here, the result of the colors is this. Just the 4 columns. In the result you can see here, 1, 2, 3 columns in the ends of the fence here. Let's see from the beginning. I just create a simple box, squashing the Y, match the size just to align with the bottom of the word. I apply some subdivision here, just to make a switch with polish and just proxy bounding box. Apply a random P scale for all the points. I transform a little bit the points in the Y and apply the bevel. That's why I use the P scale, because the P scale is driving the bevel intensity here in the distance. If I disable the P scale, all the bevel should be the same. But I don't like the same bevel in entire edges. I like some variations here. The other, I create another bevel here. This switch is just using for, there's an option here in the bridge, for example. Here you can see a resolution. There's a switch for proxy, just a bounding box of each geometry. Low poly, you can see the divisions here. And the high poly. High poly, you can see even the bricks details here. Let's dive inside again. I scale down this brick here and match sides, and the match size with the base brick, match size with the Y maximum position, and merge both together, just like this. I scale a little bit up, apply a normal node, lift a little bit, and create the base column here. Let's dive inside. Just a simple subnet. I create a box using taper just to expand the bottom. I match the size with the bottom of the word, align the bottom with the center of the word. Scatter a few points. I Voronoi the fracture. Apply Voronoi fracture here. And I polybevel. Apply a normals because I just want out the faceted. Scale down a little bit. And using the assemble just to make the package primitives, I just apply some random variations here in the rotation and the scale. Here, for example, you can see the random rotation and variations in the scale. That's it for the column. And merge both together. Apply some color here. That's the column. And to copy all the columns for each point here, first we need to create the pavement, because this is a reference to the pavement, but let's show how I created the pavement here. I import the spline, resample the spline a little bit, apply a sweep, ribbon styles here with the modifications in the columns and the width, and apply some wax here just to make the curved profile in the bridge. The wax is pretty simple, just that, using that ramp, you can apply that ramp in the lift in the Y position of the points. That's the pavement curve. Let's go back here just to see how I created the pavement. Import the pavement flat, which is this node here. Triangulate the 2D. Divide. Just to remove inside the polygons and edges. Facet it to remove the inline points. I just want these 4 points here in the edges. Convert line. And I sort the points based on the rest length, just to remove the small length splines. Here just to make the normals and up. And here I copy each columns here, Voronoi columns, to each point. And that's it. Simple as that. The column. Now let's see back the pavements. And later, after the pavement, we are going to see how I created the walls. Pavement here, curved. Let's see the result first. That's the result of the pavement. Now let's see the step by step. First, I flat back again the pavement, just to apply the scale in the Y0. I divide and remove the middle. Remove the inline points. Poly extrude a little bit. Match the size to a center with the word. And create a bounding here. Let's go here. For creating the tiles, we're going to use the copy, the new Copernicus. Let's dive inside. I just create a simple tile pattern here. Nothing complex, just change here the pattern type to French pattern and apply some uniform scale, just that, and create an out node here. Here, when you import the Copernicus back to the SOP, we need to trace that back to geometry, because this is just a texture applied to a plane. You can't handle that geometry here, just after the trace. Then I rotate back to the ground. Remove the inline points, because there's a lot of points here after the trace. Facet here. Copy in the horizontal direction and copy in the vertical direction. Fuse the connections together. Divide it to remove the connect the edges. And match size with the word. Here, this bounding. I use some vex here. You can explore this vex later. Just for example, if I want to create this line, not align it to X or Z position, I need this vex here just to understand the rotation of the line. For example, for creating the bridge, let's go back to the proxy here. I'm using these 2 points here. Start point, end point. But these points, where another point, there's a point here, and another point here. If, for example, these points are aligned to the x-axis, but if I need to rotate this, to move this different position, just to make diagonal, if I connect these 2 points just to see, let's merge this, add. When I connect these 2 points, this 2 point right now is in diagonal, but in the bridge here, the result should be diagonal too. I use that vex here just to grab the rotation of that spline and apply back to the styles here. And you can see that I match the size the bricks, poly extrude the ground, the pavement, apply a boolean just to extract the area that needed to apply to the bridge, and I rotate back to the original position, to that spline position here. And I transfer some attributes here, like a curve U, just to apply the lift. That's the trick. I need to rotate back, apply the curve U from that geometry, and use the curve U just to lift the bricks. I apply a poly bevel, make a group. Let's see what is this? Vex up. This is just the pavement ribbon, poly extrude, and I merge this both together. That's the result of with low poly here. Let's see the high poly. Here is the high poly result. Now let's see the other side. To create these bricks here at each side of the pavement, I extract the borders from that pavement curve here. Just extract the outline. Facet to remove the inline points. Fuse. Convert line. Sort perimeter by length. And keep the both longest splines here. Convert line again. And resample around the 1 meter here. Create a polyframe for normal and up. Create a sweep just to make the ribbon here. Here you can see this ribbon here is the sweep here in the ribbon is reversed. We need to reverse that and make unique points for each polygon here. Scale a little bit each primitive, like 0.95. Subdivide, poly extrude, create a randomize in the P scale, poly bevel again, apply another normal, lift a little bit, make the color, and merge with the road. That's the result of the pavement. Now let's see the result of the walls. For creating the walls, I just import the splines, resample the spline a little bit. Let's see this for each at the side what I have done. Just I squash the curve here. For each spline, I apply some scale, match the size with the original spline. I group the ends here and scale the ends back and merge together. Attribute delete for all attributes, resample back, smooth the curve, make a sweep, facet to make unique points, scale the primitive back, subdivide, poly extrude, P-scale randomize to make the bevel different for each edge. Now let's see the result of the other side here, the walls of brick. I grab each spline, apply transformation, scale the primitive, match the size with original spline, group the endpoints, scale the ends, merge together, apply the skin. I apply the bounds using sort by Y. And I use some vects here to grab the transformation bounding box. The matrix, we need this matrix to apply the rotation back to this Copernicus texture here. I did the same trick. Just create a Copernicus with a tile, trace to transform this in geometry, remove the inline points, copy this around 4 times here, fuse to make these connections here, these guys here, divide to remove the edges between, facet to remove the inline points, and match the size with that bounding box and transform it back this to the initial position. Extrude the front, extrude the back. There's an edge loop for each brick here. I use that flat edges to remove the edge loop for each brick. I use the reverse because all the bricks are reversing the normals. Reverse to fix the normals. Subdivide a little bit. Randomize again the p-scale and apply a polybevel. That's the result of the polybevel. And here you can see the result with a boolean, because we are going to make a boolean from that geometry to that geometry here. That's the result. Create a group and apply for both splines. Apply some randomization in the scale and the rotation using Vax here. That's the script to make each brick a different scale and rotation. You can apply real rotation and apply the different scale here. And merge back. That's the final arc, the wall. Now let's see the fence. The fence, I'm using again the spline. Resample the spline a little bit. Delete all the attributes we don't need. Create a polyframe to make the normals and up. I create a box here, stretch box, match size to align with the ground, polybevel the top, and fuse the top points, and polybevel all the edges, like this. And here, I just grab the endpoints, blast all the endpoints, resample again that spline, and use that point to copy each wood in the fence. I apply some boolean here. Let's see on the other side. We have the spline, sweep to make the horizontal wood, lift a little bit, polybevel all the corners, and make a boolean from that guy to that guy here, just to make a small detail. Use the assembler, add, we just need to add the points, the centroid, and copy a little box here, just to merge and make that detail here. We have an option here. Let's see, we have an option here to rotate the fence up and make the fence align with the normals. Just apply the normal node here after the merge, color the wood and lift it a little bit. That's the result of the fence. And the last part here is the terrain. The final terrain is this, just like island in each side. Let's see from the beginning. We're just import the silhouette ground, just a plane, represent the flat pavement, convert that to spline using sort. Just keep the small parts here, the small splines. Extract the centroid for each spline. And copy a big sphere here at the end. I poly extrude the pavement, match the size in the Y position and make a boolean here. Just to crop the spheres, make the subtraction from the box. Transforming the Y like 0. Triangulate 2D. Facet to remove line points, divide and clean. Just to get the silhouette in the Y position, the Y direction of that spheres. Facet again, fuse, resample to smooth the edges, apply another smooth, resample again, apply the polyframe just to make the tangent normals. Here we apply the attribute noise, poly extrude the bottom, scale the bottom just to make just elevation, divide that, match the size with the ground, apply the colors, and make a group called the dirt. Now the grass part, just the match size, poly expand a little bit the edges, apply attribute noise to make the variation at the edge at each point at the border. Apply poly extrude, apply the color itself, apply the remesh and the smooth. Apply a group grass, and that's the result of the terrain. Using normals to make all the geometry faceted, clip the bottom, we don't need just the lower bottom, and that's the result of the terrain. Let's see the result of the bridge. That's the result of the asset. We have the colors, color the wood, color the bricks, color the pavement, and color the column. Now we merge all together to see the result. But the result here, we create a lake too. To create a lake, we need to output that geometry here. The terrain should be using in that lake node to make the lake below of the bridge. We're going to import here the bridge, import the start and end position of the bridge, merge both together, scale in the Y direction, create a line connected, point jitter a little bit, resample that line, apply a polyframe in the bitangent using normals, and I create a curved arc in the spline for both sides, left side and right side. Merge both together and fuse. Convert all this to line, sort by vertex order, because we need to connect all these points back to the closed geometry here. We import the terrain, just keep the grass and merge with the ground here, that polygon here, that ellipse. Flatten the Y, triangulate 2D just to remove the inside edges, divide, facet, resample, poly expand a little bit, smooth the borders, Change the color to white. Make a lot of divisions here, just to apply the alpha in the edges here. And apply the colors and make the smooth at the edges. To make the movement in the water, I'm using the Ocean Spectral and Ocean Evaluate. This Ocean Spectral is for creating the movement, fractal movements in the oceans. I'm just using here just to create the noise at the lake here. You can see by the change of the specular, the movement of the water. With normals, now that's working. We can see by the specular the movement of the lake. And that's the result of this project. The final render. I just did the final render in Redshift. You can download for free this asset at Gumroad. The link is in the description. You can download, study, understand how I use this procedural network to create the entire bridge. Thank you guys. See you at my next video.